Okay, today let's look at dividing expressions that have exponents. Okay, so here are two examples that I made up before we get into the problems, so you can see the idea behind it. Okay, so the first example on the left, if I wrote out x to the 7th, 1, 2, 3, 4, 5, 6, 7. Remember that means x multiplied by itself 7 times. The base is x, 7 is your exponent. In the denominator, I would have x multiplied by itself 5 times. Okay, what happens when we have the same value in my numerator and denominator? Well, x over x, those simplify to be 1. X over x is 1. Okay, so every time I have the x in my numerator and denominator, okay, I can divide those out. So those are all 1, but 1 times anything, 1 times x is just going to be x again. Okay, so what do I have left over here? I have x times x, well that's x squared. Okay, on the bottom I have over 1, but I don't have to write that 1. I can just write x squared. Okay, so x squared or x squared over 1 would be my answer there. Okay, let's compare it with the problem on the right. Okay, on the right, for my numerator, I have y times y times y. For my denominator, I have y times itself 6 times. Okay, and we're going to divide out those same terms. Y divided by y is 1, 1, 1. Okay, so this time in my numerator, I'm left with 1. And in my denominator, I have y times y times y. That should be y to the 3rd power. Again, not 3y, y cubed or y to the 3rd power. Okay, so sometimes you'll have these variables left over in your numerator, sometimes in the denominator. Okay. What you are looking for is the pattern or the relationship between the exponents in your problem and the one in your answer. So 7 and 5, what do you have to do with those two numbers to turn it into a 2? Well, it should be subtract them. Right, 7 minus 5 is 2. On this side, in the problem, your exponents were 6 and 3. And back in your answer, your exponent was a 3. Well, subtraction still works, right? So when you are dividing with exponents, you have to subtract your exponents. Okay, so let's start looking at some of these even problems. And when we do these, we'll do the shortcut. We'll try to subtract the exponents. Okay, so here in my numerator for number 2, I have 3 to the 1st power. Okay, if there's no exponent right, and you can put a 1 there, divided by 3 to the 3rd power. Okay, so my bases are the same. I can subtract these exponents. 3 minus 1 is 2. But where are those 3's going to be? Do I have more 3's in the numerator or denominator? It should be in the denominator. Okay, so you don't have to write this, but there are more 3's in the denominator. Okay, so when I divide these, I'm going to have 3 squared left, but it's going to be as my denominator. Okay. We'll draw this one out on the other side. Okay, so on the top I would have had 3. In the denominator, I have 3 times 3 times 3. Divide those ones out. So the numerator was left with a 1, and the denominator was left with a 3 squared. Okay, so first, when you have like bases, well, it's a division problem. When you're dividing with like bases, you can subtract your exponents. Okay, 3 minus 1 in this case, we got the 2. But we have to decide if that goes in the numerator or denominator. Okay, so decide if your expression goes in the numerator or denominator. Okay, and the way we did that was there were more 3's in the denominator, so our expression stayed in the denominator. Okay, now some of these you can write out, okay, because the exponents aren't so large. Okay, but we want to start using the rule in case you have really large exponents. Okay, so here, I have the same bases. I'm dividing, so I can subtract my exponents. Okay, do I have more 2's in the numerator or denominator? Well, I have 2 times itself 4 times in the numerator, so I have 4 2's in the numerator. I only have 2 in the denominator. So when I divide these, it's going to be left in the numerator, and then subtract the exponents. 4 minus 2 is 2. Okay, and I can put a 1 on the bottom as a holder, but dividing by 1 doesn't change anything. Okay, so your teacher probably will not write that 1. All right, let's look at some of these problems that have numbers and variables. Okay, so first we'll do the numbers. Okay, 7 and 4. Okay, if I have the fraction 7 over 4, I cannot reduce that at all. They don't have any common factors. So the 7 and the 4 are going to stay the same. Okay, k squared on top and k cubed on bottom. So I'm going to subtract those two exponents. 3 minus 2 is 1. And I have more k's in the denominator, so I'm going to have k to the first as my denominator. Okay, so when we have these numbers and variables, we'll handle them separately. So 3 over 10, can I reduce that fraction? Okay, if I try in the calculator 3 ABC 10, it doesn't reduce. I still have 3 over 10. I have 1b in my numerator and I have 3 in my denominator. So when I start canceling those out, 3 minus 1 is 2. I'll have b squared left in my denominator. Here I have 7 over 2. Nope, no common factors. I cannot reduce 7 over 2. I have n to the third in my numerator. I have n to the fifth in my denominator. Okay, so there are more n's in the denominator. N is going to stay in my denominator. And then 5 minus 3, subtract my exponents. 5 minus 3 is 2. All right, here's an example where we can reduce the numbers. 8 over 10. Okay, they have a common factor. 2 goes into both of those. Okay, so we can divide those both by 2. So for the numbers, 8 divided by 2 would be 4. 10 divided by 2 would be 5. So for the numbers, I have 4 over 5. I can reduce them this time. For the variables, I have x to the third on top, x to the fifth on bottom. I have more x's in my denominator. And then 5 minus 3 is 2. Okay, here's an example with numbers with then two different variables, x's and y's. Okay, so for the numbers, 14 and 6, well, 2 goes into both of those. 2 goes into 14 7 times, and 2 goes into 6 3 times. So for my numbers, I'm going to have 7 over 3. When I'm looking at the x terms, x to the fourth over x to the fifth, so those have like bases. I have more x's in the denominator, and when I subtract the exponents, 5 minus 4, I get 1. For the y terms, I have y to the seventh over y to the fourth, so I have more y's in the numerator. Okay, put my y in the numerator, and then 7 minus 4 is 3. Okay, I think we have 3 more even problems left to look at. Okay, so for the numbers, 4 and 14, I can reduce that. 2 goes into 4 twice. 2 goes into 14 7 times, so 2 sevenths. For the y's, I have y to the fourth divided by y to the first, and more y's in my numerator, and then 4 minus 1 is 3. The x's, I don't have any x terms in the numerator to simplify it all, so I'm going to leave the x alone as it is, x to the 8th in my denominator. Okay, our last two. 18 over 10, I can reduce. They're both even. Divide them by 2, I get 9 over 5. X to the 8th and x to the 3rd, those have like bases. I have more x's in my numerator, and then 8 minus 3 is 5. And the y, I don't have anything to simplify it with, so I'm going to leave it right where it is. I have y to the 8th, that's going to be my numerator. Okay, one last one before you guys try some. Okay, 16 over 9, there's no way to reduce that. I'm going to leave it 16 over 9. All right, here are my x terms. They're not right on top of each other, but I have more x's in the denominator, and then 8 minus 4 is 4. Okay, for my y terms, I have y to the first divided by y to the second, so I have more y's in the denominator again, and 2 minus 1 is 1. Okay, if you have an exponent of 1, again, you don't have to write that, so you can write just y instead of y to the first power. Okay, here are some odd ones for you to try out. Okay, this first one, remember 5 to the first, so you have 5, 4 minus 1 is 3. So 5 to the 3rd power over 1. But again, if the 1 is in your denominator, dividing by 1, you don't have to write that. So just 5 to the 3rd is fine. For number 2, subtract your exponents. 3 minus 2 is 1. Okay, this time you do need a place value holder in the numerator, because this one's going to be a fraction, your answer. And for number 5, the numbers stay the same, but you have r squared left in your numerator. Okay, look at number 7 and 9. Okay, 7, you can reduce the numbers. 5 over 3, and left in the numerator is p to the 3rd power. For number 9, reducing the numbers, 4 over 5. Now m to the 3rd over m to the 3rd, those divide out. You're left with 1, okay, but you don't have to write times 1. Your final answer is just going to be 4/5 there. Okay, here are your answers for 11, 13, and 15. 11 is 2n, or 2n over 1. Okay, you can reduce those numbers, but the variables stay the same. They don't have like bases. And then the last one, okay, please try 17 and 19. Okay, in 17, you can reduce the numbers. The y variables divide out. Y divided by y is 1. But again, 1 times anything stays the same. And then in the last one, 5 over 20 you can reduce. N to the 8th over n to the 8th. Okay. You can say that's n to the 0. Remember, anything to the 0 power is really just 1. So your final answer there is just 5. 5 over 20 could be reduced to 1 over 4.